Why is understanding quantization error crucial for DSP? Imagine trying to capture a beautiful sunset in a photo, but your camera only has a limited number of colors. The picture might not look exactly like the real scene. That's similar to what happens in digital signal processing when converting real-world signals into digital form. When we turn an analog signal into digital, we use a process called quantization. This process assigns the continuous amplitude of the signal to the nearest available digital level. But because there are only a finite number of levels, some details get lost. This loss creates what we call quantization error. Understanding this error is important because it directly impacts the accuracy of the digital signal. If the error is too large, the digital version of the signal will not match the original well. This mismatch can introduce noise, which is like static or fuzziness in the signal. This noise, known as quantization noise, can make audio sound distorted or images look less clear. In systems like control systems, where signals guide actions, this noise can even cause instability or poor performance. In digital signal processing, the quality of the final output depends heavily on how well we manage quantization error. If we use a low number of bits to representing each sample, the error is bigger. Increasing the number of bits reduces the error, making the digital signal more faithful to the original. For example, audio recordings often use 16 bits or more to keep the sound clear. Telecommunication systems also use higher bit depths to ensure messages are transmitted accurately. Engineers use techniques to minimize quantization error. Dithering, which adds a tiny amount of noise before quantization, helps make the error less noticeable. Choosing advanced quantization schemes can also help keep the error within acceptable limits. When designing analog to digital converters, or ADCS, the goal is to find a balance between resolution, cost, and complexity. Higher resolution ADCS cost more but give better accuracy. In practical applications like medical imaging, audio processing, or radar systems, managing quantization error is key to maintaining signal integrity. If the error isn't controlled, the process signals can become unreliable or distorted. That's why understanding quantization error helps engineers choose the right resolution and techniques to produce clear, accurate digital signals. It also guides them in designing systems that perform well without unnecessary expense or complexity. In summary, knowing about quantization error helps in designing better digital systems because it sets the limit for how accurately signals can be represented after conversion. It influences noise levels, distortion, and overall system performance. By understanding and controlling this error, engineers can make sure the digital signals they work with are as close to the real thing as possible, leading to clearer audio, sharper images, and more reliable control systems.